Hi, my name is Nafarisha binti Muhammad and I'll be presenting about the introduction. So, firstly, what is laser beam shaping? As shown in figure 1 is the schematic diagram of laser beam shaping. Laser beam shaping is a process of redistributing the irradiance and phase of an optical radiation beam from an input plane to an output plane. For simple understanding, laser beam shaping process is a process that transforms the laser original beam profile, as you can see here, to the shape beam profile by using the filter Fourier plane. So we can get any shape that we like. Next, what does laser beam shaping do? The laser beam possesses the characteristic of Gaussian energy distribution in many application fields, such as in laser processing, laser welding, and laser medicine. The uneven distribution of energy will induce the high local temperature. Therefore, in eliminating the negative effect of uneven temperature, Gaussian beam has to be converted into a platinum beam with evenly distributed energy. Next, what is laser beam? Gaussian beam are typically produced with a Gaussian intensity distribution. Flat-top laser beam are more useful in laser welding, laser microfabrication, laser scanning, and more. But what we need to obtain in this mini project is this Gaussian beam shaping. To obtain this Gaussian beam shaping, we need to automatically optimize the design of Gaussian beam shaping system by using the Zemax software. Furthermore, is the technique used in this mini project. Various techniques of beam shaping available, such as aperture shaping, diffractive optical element shaping, aspirate lens shaping, and others. When comparing to other techniques, aspirate lens shaping is the best option as it has an effective method with high energy utilization and temperature resistance. The objective of this project is to study the principle of Gaussian beam shaping theoretically. Second is to design the Gaussian beam shaping system by using Zemax software. And third is to optimize the Gaussian beam shaping automatically. For the problem statement, nowadays shaping the beam profile can be accomplished in many different ways. Each shaping technique has advantages for particular application. So, which technique is the best to design the optimized Gaussian beam shaping automatically? Based on the research paper, we find that aspirate lens shaping techniques have many advantages compared to the other technique. So, it's more suitable for high power lens beam shaping. The next point is why we use Zemax software. The reason why we use Zemax software because it offers unmatched software solution for optical products. Therefore, our aim to design the Gaussian beam shaping system will be achieved. Furthermore, this optical design software is ideal for imaging system, a focal system, laser system, fiber coupling, and more. Next, how Zemax programming language ZPL helps in this project. Zemax programming language is used to compile the macro order to extend the optimization function. However, by using the Zemax programming language, the radial coordinate can be calculated automatically. The last point of the problem statement is the choice of the distribution of the platinum beam is crucial. Several analytic functions with a central region have been studied. Usually, the platinum beam can choose the function such as super Gaussian function SG, platinum Gaussian function FG, Fermi direct function FD, super Lorentzian function SL, and platinum Lorentzian function as shown in table 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amizah binti Muhammad Salihani and I'm from Electronic Engineering, RK86. Okay, So my part, I'm going to present on the literature review. Okay, the first paper that we review is Technique 1, which is with the title of Automatic Optimization Design of Gaussian Beam Shaping System by using Zemax software. Okay, the beam shaping technique that we use the beam shaping technique that is used in this research is aspirate lens by flattening the Gaussian beam. Okay, it is suitable for high power laser beam. It is because it has, first thing first, because why it's suitable for high power laser beam. One is because it's high resistant towards temperature, and as it has a high resistance towards temperature, relatably it would use high power consumption. Okay, so this system, it can record a large amount of measurement and optimize the system simultaneously, meaning that if it has received a large amount of input samples, it can still precise the sample and also optimize the sample. It can and also optimize the sample as well. Like it can do two tasks at once, so you can get the result faster instead of doing the traditional method, which is one by one, and it will consume a lot of time. Okay, the software that we use here is Zemax, and also Zemax programming language, and the number of input rays that they use in this research is 200 input samples, and it is proven that at the beginning the input samples is unevenly distributed, and at the output rays, the rays are evenly distributed. Due to this, the calculated rays are in a short time, measurements in a short time, as well as you can optimize it. So this is a proven method for that. Okay, the next technique is automatic optimization. The next technique is irregular surfaces measurements and Zemax simulations. Okay, this paper study on irregularity surfaces produced on optical units that hold the effect on the performance of the system. Meaning to say here that the previous technique 1, we says that the input rays are unevenly distributed. So here, they study on the effect of the irregularity effect on the performance of the optical system. So in this, they use grid mode in Zemax, which is grid phase and sag, and also Zernica fringe phase and sag. The result report from here, this paper is it is proven that irregularity of surfaces produced has affected the performance of optical unit system. Yeah, it can affect a lot of things because optical, depending on the reflected rays, and also if the reflected rays are reflected on different angles and everything, it's going to affect the overall performance that we desire it to perform. Okay, the next technique is Technique 3. It is with a title of Non-Sequential Modeling of Laser Diode Stack using Zemax in terms of simulation, optimization, and experimental validation. Okay, in this paper, they use laser diode stack. Previous paper and a lot of research have been going on laser ray tracing. Okay, so what's different with this paper? They use laser diode stack, which is the fixed amount of stacked bars, and each and every bar consists of fixed amount of diode emitters array lined along the bar. Okay, and this laser diode stack technology has replaced a lot of flashlight technology, of the traditional flashlight technology, and it is proven that this laser diode stack has a better technology in terms of performance compared to the traditional flashlight. Okay, why is it so? It's because the efficiency in the conversion process of electrical to optical, and then the low gradient of thermal produced due to the efficiency of the energy conversion, as lesser heat produced during the conversion and lesser energy are lost to the heat, and then also longer lifespan because the product has a kind of has a high temperature during usage. Then it will result to a longer lifespan because the product is not running at the maximum capacity, as well as it's losing its energy through heat. So this one has a very low gradient thermal produce, so it has a long lifespan. as well as the quality of the beam. So when the energy conversion is very efficient, the quality of the beam also will improve. Like you can see, like the normal light and also the LED has a lot of difference. Same thing here. Okay, so they use software Zemax, and the method approach they use in here is near field and far field. Meaning near field and far field is that near field is a shorter distance and far field is a longer distance. And the result they got here is they calculate the distribution of pump energy in active material of diode solid-state laser system. It's capable of calculating it, and also it can optimize the performance of the laser system in the thermal lens, as well as it can improve the quality of the beam factor, and it can also improve the efficiency of the pump extraction. So we use these 3 literature reviews that makes for our mini project. So that is all from me. Thank you.
Assalamualaikum. Hi, my name is Nur Syahirah binti Nur Azmi. I will be presenting on the methodology of our project. Figure 1 shows the flow chart of our project. First, we start this project by doing some research related to our project title. In this project, the principle of Gaussian beam shaping was studied theoretically, and Lorentzian flattened beam function is chosen as the flattened beam distribution. Then, followed by the second step, which is we check and test the parameters that are set to design the Gaussian beam shaping. Next, we proceed by running the simulation step. After done setting up the parameters configuration, if there is an error, we troubleshoot the error by changing or resetting the parameters until it is a success. After the simulation runs successfully, the output result is collected and analyzed. If the data does not satisfy the objectives, the parameter setup are changed until it meets the requirements. Next, I will present the parameters of the shaper that we use to design the shaper as illustrated in the table 1, and the coefficient asperics of the shaper that we use to design the shaper in the Zemax software as illustrated in table 2. For the first surface type, we use top, which has the radius to infinity and the thickness into 5, and the glass type is silica. For the second surface, the radius we set into negative 22.3069, the thickness is 140, and the glass is air. The third surface type, we set the radius into 45.170116, the thickness into 5, and the glass is silica. And the fourth surface type, the radius we set into infinity. The thickness is 150, and the glass type is air. For the second and third surface type, there are even sphere.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Haryani Syafiqah binti Abdul Aziz, and I'm going to present the result and discussion of this project. Result of this project and discussion regarding an automatic optimization design of the Gaussian beam shaping system by using Zemax software is discussed in this chapter. Firstly, the principle of Gaussian beam shaping was studied theoretically, and the Lorentzian flattened beam FL is chosen as the flattened beam distribution. In addition, the method of automatic optimization design of Gaussian beam shaping by using Zemax software is discussed in this project, and the macro order is compiled using the Zemax programming language ZPL to achieve the optimization process automatically. So, after after plugging the information of parameter in the Zemax software, we obtain the result as shown in figure 4.1, figure 4.2 and figure 4.3. Beam shaper shown in figure 4.1 is the layout of the optical system, while in figure 4.2 and figure 4.3 is the energy distribution of the input and output beam. The abscissa represents the coordinate value of the luminous spot, which the longitudinal coordinate shows the normalized energy distribution in unit W per mm square. Besides, the center intensity of the Gaussian beam is set as 1. According to figure 4, the Gaussian beam transforms to the flattened beam and the center energy distribution is quite uniform. The edge shows serious energy fluctuation, but this fluctuation has little effect on the high power laser machining.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naira Izzati binti Ahmad Nazli. Today I will continue the result and discussion. Figure 4.4 shows the intensity distribution of the input beam, while figure 4.5 shows the intensity distribution for the output beam. The intensity distribution of the input beam and output beam are shown in figure 4.4 and figure 4.5 respectively. The graph of the intensity distribution for both graphs was plotted using relative intensity over radii. As we can see from figure 4.4 and figure 4.5, the Gaussian beam is converted into flattened beam. When the input beam has a proper size, the resulting profile is a flat top. Increasing the input beam diameter leads to decreasing of intensity in the center, and this distribution is sometimes called an inverse Gaussian distribution. This considered intensity distribution corresponds to about 10% beam size change. The stability of the output beam size is also an important feature in beam shaping, where a variation of the input beam diameter results in variation of the intensity distribution, while the output beam stays almost invariable. Meanwhile, the usage of compiling the ZPL macro makes the system optimized automatically, and all of the operation can be input simultaneously, which greatly simplifies the process of design. In fact, this method also can be applied to special high-order model Gaussian beam shaping by choosing appropriate models. This method is simple and easy to achieve without tremendous calculation, and it has significant engineering application value. However, we cannot run the ZPL coding. This is because we don't have a proper software to compile the ZPL coding. The third objective in this project cannot be achieved due to these problems. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aniza binti Muhammad Salhani and I'm from RKJ6 Electronic Engineering. Okay, so my part, I'll be presenting the conclusion. So what I can conclude from this project is the method that we use in this Zemax software to transform the Gaussian beam is by flattening the beam. It is by using the method approach of aspirate lens. Okay, so the usage of ZPL versus Zemax has significantly improved the process in obtaining the results, because it can process a lot of input rays at one time, and also while it take the measurements of all the input rays, it can also optimize the system simultaneously, so it kills two birds with one stone. Okay, and then this method also has significantly improved the overall design of the system, meaning that the output you will get a better design system. So a simplified design system, you can easier to troubleshoot, easier to upgrade, okay, easier to detect where's the problem, okay. And this method also is specialized for high order model Gaussian beam. shaping by using appropriate model, because there are a lot of modeling to be choose from to apply in the Gaussian beam. Okay, and it is undeniable that using Zemax and also Zemax programming language has simplified our job in obtaining the result for our mini project, because we can program the system that we wanted, so that the Zemax can calculate it and also evaluate and measures it, as well as the Zemax software to evaluate and analyze the Gaussian beam. However, partly of the objective can be fulfilled, but not one. Okay, the first two we can fulfill the objective, we accomplish it, which are to study the principle of Gaussian beam shaping theoretically, and also to design the Gaussian beam shaper using Zemax software. Okay, and but then the optimization of Gaussian beam shaping automatically by using Zemax programming language cannot be completed due to software malfunction. Not software malfunction. Software is not supported by that. Okay, so we did try to do the ZPL coding in the Zemax programming language. However, the Zemax software that we have in our computer does not support the Zemax programming language. So the limited features available in the Zemax software make it impossible to achieve the optimization of Gaussian beam shaping automatically. That is all from me. Thank you.